Okay, let's get into the hypothesis test itself. So at the top of page 2, you see the hypothesis test. It's also sometimes referred to as the p-value test. I'm not going to refer to it as that, but you might see that in other resources. All right, so it says to test a claim, we will use a significance level and the mean from a sample. So we'll have these two important values that we'll begin with, that will be told in the problem itself, the significance level and the mean from a sample. What is the significance level? This is a predetermined probability, denoted alpha. Okay, typical values of alpha are 0.10, which would be 10%, right? 0.05 or 0.01. Again, these would be told to us in the problem, a predetermined probability. We'll see how the significance level comes into play when we do the test and see all that. All right. Then there's the test statistic. So the test statistic is the z-score associated with the sample mean. So we'll be given the sample mean in the problem. We will find the z-score that is associated with that. And this we refer to as the test statistic. So it's actually, this is nothing new. We found these z-scores many, many times by now. But when it comes to hypothesis testing, we give it a new name. So where we just referred to it simply as the z-score in the past, now we give it this, very prestigious, I don't know what we want to say, this very formal name, the test statistic. Okay, but it's really just a z-score. All right. And then there's the p-value. This is the probability that the sample mean to occur if the null hypothesis is true. Okay, so it turns out the p-value is the probability that is associated with that z-score. So, right, so if you find a z-score, then you can find the probability that goes with that z-score. Again, we've done this many, many times already, but now we give it this new name called the p-value. Okay, and hence kind of why sometimes this gets called the p-value test. All right. Here are the steps to perform the test. Number 1, state the null and alternative hypotheses. So we will practice that every time. Number 2, now we get into the calculations. Number 2 is calculate the test statistic from the sample data. Again, that just means to find the z-score. Number 3 is to find the p-value. Well, that's the probability that goes with that z-score. Number 4, compare the p-value to the significance level. Okay, so finally in step 4, the significance level that we would be told in the problem comes into play. We compare the p-value we just found with that significance level. And I'll show you what we mean by compare. We're really just looking at which one is bigger, which one is smaller by compare. And then step 5, based on that comparison, we will be able to decide to either reject the null hypothesis or fail to reject the null hypothesis. Okay, step 5 is interesting. You notice that it's all based around the null hypothesis. We either reject the null hypothesis or we fail to reject the null hypothesis. All right, so again, kind of think about that innocent until proven guilty. So if you reject the null hypothesis, that's like proving the defendant guilty. You reject that they are innocent, right? Right, we assume the null hypothesis just like we assume innocence. So if you reject the null hypothesis, then you fall to the alternative hypothesis. But we don't say it that way. We say we reject the null hypothesis. There's enough evidence to prove them guilty, if you will. Or maybe you fail to reject the null hypothesis. There's not enough evidence to show that they are guilty, right? So maybe there was some evidence, but not enough. So you would fail to reject it. Well, if you fail to reject the null hypothesis, then you have to keep the null hypothesis is kind of the idea there. And so The equivalent in the trial would be, well, maybe there's some evidence that they are guilty, but not enough, so we fail to prove them guilty, right? So in other words, they're off the hook, right? Okay, if that's not confusing enough, let's go ahead and see it in a problem. Maybe that will clear things up. Practice number 2. Still going back to that Carl's Jr. example. Now we're going to do the whole thing. This is great. A manager at Carl's Jr. wishes to know. We're finally going to get an answer. A manager at Carl's Jr. wishes to know if the average salary of managers in the company is more than the national average of all fast food restaurant managers. The national average is $42,000 per year, but a random sample of 30 Carl's Jr. managers has a mean of $43,260 per year. Also, the standard deviation of the larger national population of managers is 5,230. So there's definitely some new info there. We're going to need to know a standard deviation in order to find the z-score, etc. Okay, then it says, at a significance level of alpha equals 0.05, is there enough evidence that managers from Carl's Jr. average more than $42,000? So you see they give us the significance level there of 0.05, in other words, 5%. We're going to see how that plays in to this whole process. Okay, so you notice in practice 2, we have parts A, B, C, D, and E. We're going to break down the steps to the hypothesis test in each little part. So we'll be sure to hit each of the 5 steps. Okay, so part A, what are the null and alternative hypotheses? Well, we did this already back in practice problem number 1. So I'll just show you here. So this is part A. I'm calling it step 1. That is step 1 of the hypothesis test, but it's part A here as well. All right, so step 1 to the test. The null hypothesis, we assume that Carl's Jr. managers make the same as everybody else. So mu equals their average equals $42,000 per year. The alternative, H1, is that their average is actually more than $42,000 per year. We base that on the way the question there at the end is phrased, right? Is there enough evidence that managers from Carl's Jr. average more than $42,000? Okay. So let's go to part B. Calculate the test statistic. Again, this is simply the z-score that comes from our sample data. All right. So we're going to use, this is part B now, step 2 of the test. We're going to use the formula for the z-score that we used back in the central limit theorem. All right, since this is based on a sample. So z equals x bar minus mu over sigma over the square root of n. Okay, let's find this z-score. Well, let's fill in the different parts. What is x bar? And you think, okay, x bar, that's the sample mean. Finally, that's where we use the 43,260. Let me see, I've got my work here. Just ignore this for now. So that x bar, 43,260. Minus mu. What do we put in for mu? Okay, and you can see it's the 42,000. Why? Again, right, we assume the null hypothesis. So we assume that mu equals 42,000. So, okay, well, if we're assuming mu equals 42,000, then I can just replace that with 42,000. Okay. Then we divide, and we've got our sigma. Right, standard deviation is 5,230, and that's divided by the square root of the sample size, n, which is 30 here. Okay. So then, of course, we will compute that. And if I was to do it here in my calculator, right, 43,260 minus 42,000, I might even just do that first and then divide by parentheses 5,230 divided by the square root of 30. Close all my parentheses, hit enter, and I get 1.31956 and so on. It's a z-score. I'm going to go ahead and round it to 2 decimal places, 1.32. Okay, so hopefully you can calculate that value as well. So, and I'm kind of saying, hey, we're not calling it a z-score anymore. That is our test statistic. So we have finished part B. 1.32 is our test statistic. Okay, very nice. Let's go to part C. This is step 3, part C. Step 3 in the test is to find the p-value. All right, so the p-value is the probability that goes along with that z-score, that test statistic. So the p-value is equal to the probability, and notice what we have here. Okay, so we filled in the z-score. Notice there's a greater than. All right, let me erase that and kind of talk this through. So the p-value, the probability that z something 1.32, and we'd have to think, okay, should we fill this in with a less than, right? Less than is what we would typically use, right? Or maybe it's a greater than. So I'll tell you, it's always the same as the alternative hypothesis. So if our alternative hypothesis has a greater than, then we'd like to know the probability that z is greater than 1.32. What were the chances of that to happen? What's the probability that z ends up being bigger than this value, right? Let's see how this plays out. Okay, in order to find that probability that capital Z is greater than 1.32, back a couple chapters ago, we used the table of z-scores. Nothing wrong with that. You could use a table of z-scores here. You would need to use a complement first, right, in order to do that greater than probability. But at this point, we're using StatCrunch to do all of these sort of calculations for us. So I recommend just go right on into StatCrunch, pull out the normal calculator, and find the probability that z is greater than 1.32. Now here, right, this is different than a confidence interval. You're not going to use it to work backwards. This is working forwards. Also, you're going to stick with the standard calculator. You're not going to do the between. So leave it on the standard calculator, and you will have to change this, make sure it's a greater than, and then type in 1.32, compute, and it will show you the answer. If you did that correctly, you will get 0.0934. Okay. At the same time, if you like using the table of z-scores and you would like to do this with the table, nothing wrong with that. Obviously, be sure to do a complement first, 1 minus the probability that z is less than 1.32. You would get the same result. Okay, so we have the p-value. That is part C. Now in D, the question is, which is greater, the p-value or the significance level? So let's see how this works. Step D. Letter D, part D, step 4 of the test. Compare the p-value and the significance level. Which one is bigger? Okay, so our p-value was 0.0934 that we just found. The significance level that they told us in the problem is 0.05. So there's our p-value, there's our alpha. And we can tell that the p-value is greater. Okay, so we've done part D. Now, based on that comparison, we'll be able to tell if we have enough evidence that Carl's Jr. managers really do make more money than everybody else, or we'll be able to tell maybe that, we don't have enough evidence and we cannot say for sure that Carl's Jr. managers really do make more than everybody else. Now, at this point, I like to ask the class, hey class, just based on this result here, the fact that the p-value was bigger than alpha, do you think that means that Carl's Jr. managers really do make more? Or do you think that means that, we just don't have enough evidence? We have some evidence maybe, but not enough. And this one, it's often backwards from what you might think. You might think, oh, the p-value was more. So maybe, that implies something, but it's very likely to be the opposite of what you might initially guess. So let's go to step E. Should we reject or should we fail to reject the null hypothesis based on that comparison? So it turns out we fail to reject the null hypothesis. Okay, it turns out there is not enough evidence. There is not enough evidence that Carl's Jr. managers really do make more. After all this, we don't know, we cannot say for sure that people who work for Carl's Jr. really make more than other fast food restaurant managers. You might be thinking, what? Why is that? Why is it that, maybe not that we don't have enough evidence, but why is it that if the p-value is bigger than the alpha, why would that mean that we failed to reject, that there's not enough evidence? Okay, let me explain. I think it's best done with the drawing. Let me try and keep all this. Hopefully I can fit it all on the screen. Yes, I think I can. Okay. Why? Why this conclusion based on this result? Okay, so imagine a bell curve. All right, something like that. I'm going to put what we're assuming to be the average, 42,000, right there at the center. Now, we found from our sample of 30 that those managers made 43,260 per year, right? So it's up here somewhere. But it turns out that did not make it up into this shaded region. Okay, so what's going on? Let me explain it from the other point of view. Let's say this is where the problem began, right? We've got our bell curve. We have 42,000 we're assuming to be the mean there at the center. We're also saying we need a significance level of 0.05. All right, because we're assuming that Carl's Jr. managers, we're asking if they make more than this, we put that 0.05 at the top of the curve. Okay, so we're asking, is there enough that Carl's Jr. managers make more than 42,000? So what needs to happen when we do our sample data needs to fall within that shaded area. Okay, so we put this 5% of the data, 0.05, up in the upper portion, the upper tail. Now, if our sample data, if we do all of our calculations and our sample data lands up in this upper shaded region, then that is enough evidence. Okay, so we go through, we find the z-score, right? Then we find the probability attached to that z-score. It all was based on that sample average that we took, 43,260. So we find this probability, right? 0.0934. Does P equals 0.0934, does it fall inside the shaded region or outside the shaded region? That probability that we found, does it make it up into the top 5% or does it fall short? Well, since 0.0934 is bigger than 0.05, it would fall a little bit short, right? So this top 5%, this probability, right? Remember it was the probability greater than 1.32. So this is a probability greater than. So it turns out there's some place about right there that would have 9%, 9.34% above. Well, 9.34% above does not fall inside of 5%, the top 5, right? That's at 9%. It does not get into the top 5%. So because that didn't make it into the shaded region, then there's not enough evidence. So this is where the 43,260 would fall. It's above 42,000, but it's not high enough above for us to say that we have enough evidence. We don't have enough evidence that Carl's Jr. managers make more. Now, not to say we don't have some evidence. I mean, we had 30 people and they averaged that number right there. But that average wasn't high enough in order to meet our significance level of 0.05. Okay. The second half of part E there says interpret the decision in the context of this problem. So let's go ahead and finish with that. How might we say the interpretation? We'd say, okay, we failed to reject the null hypothesis. We did not make it into the shaded region, so we failed to reject. Here's how we might say it. There is not enough evidence that the average Carl's Jr. manager has a salary more than $42,000. We cannot say for sure that if we were to look at all of Carl's Jr. managers, they would really have an average more than $42,000. So that's a good structure for how you would state. And it's really kind of at the beginning. There is not enough evidence, and then you just kind of repeat the question from the beginning. If we did have enough evidence, then we would say that, right? So on the other hand, it might be there is enough evidence that the average Carl's Jr. manager, right? If our p-value did fall into that shaded region, we'd say the opposite. There is enough evidence, blah, blah, blah. But since our p-value didn't make it up into that top 5% in this case, there's not enough evidence. Okay, we need to stop our video here. We'll do practice number 3 next.